Now, before getting our hands dirty, let's talk about the last topic you need to know about, which is typical architecture topologies. There are several different architectures that may be suitable depending on your requirements. These architectures basically revolve around three axes: centralized versus peer-to-peer, and mixing versus routing. Okay, so for simplicity, let's forget about signaling and eyes for just a second and focus on the actual call. Just keep in mind that we still need these two. This is the WebRTC topology that we know, peer-to-peer. While this is a simple approach for two users, it can get a little more complicated when more users want to join the party. This topology is called mesh. And under this approach, each browser is responsible for managing as many RTC peer connections as users are in the call. As you can imagine, this introduced a huge resource load to each client, and eventually, as more users join, the call will simply break. This takes us to the next topology, mixer, also known as MCU, which stands for multi-point conversing unit. So let's talk about the elephant in the room. You see that there is a server in the middle. This is a media server and it's responsible for receiving all the streams from all the users and send them to the others in a single connection. Here we don't have the problem of the previous approach. Users can join without having to worry about breaking the session. The only problem here is the media server capacity. An MCU media server is usually expensive, but if you have the budget, it's a great option for multi-party calls. The last but not least topology is routing, also known as SFU, which stands for Selective Forwarding Unit. In this topology, we also have a media server, which also receives all the streams from all the users. However, instead of making all the processing in the server, it simply routes the streams to all the users. This approach distributes the load between the server and the clients. This allows for the server to be less expensive and at the same time offer a comparable performance to MCU. Okay, enough talking. Let's put all we have seen into practice by creating our first WebRTC application. When you're ready, move to the next lesson.